quantitative solubility and Ksp. Quantitative solubility is the study of equilibrium position of saturated solutions. Okay, we use Ksp, which is pretty much, as you can see down here, it's the solubility product constant. Okay, what is this? Well, it is pretty much the product of concentrations of maximal amount, like we just said about the saturated solution, right, of maximal amount that can remain in the solution, which means that they're just going to dissolve readily. Okay, so there's not going to be a spillover of any leftover amount that can't dissolve. And again, this is all under a condition where it has to be at a given temperature. So therefore, any two concentration values that when created as a product, which means you have a concentration value here and you have a concentration value here, when they multiply as a product, right, because that's what a product is, okay, exceeds that maximum product. Okay, so for example, if this is our Ksp formula, if this value here exceeds the Ksp amount, this means that there will be a spillover. This will precipitate out of the solution. Okay, so for example, let's have a look here. Ksp of potassium hydroxide, let's say it's a value of 16. If I see my cations and anions over here, it needs to hit 16. If it's over a 16, then there will be an amount that will precipitate because it cannot readily dissolve in the solution anymore. It gets past that saturated point. So if this is our cation and this is our anion, they need to make 16, which means 1 times what gives you 16? Obviously 16, right? So 2 times 8 obviously gives you 16. 4 times 4 gives you 16. That means 16 times what gives you 16? It's obviously going to be 1, okay? So these are the possible ion concentrations that can exist for the K plus and the OH minus, okay? So let's have a look at this question over here. Determine the solubility product constant, which is the Ksp. So first, before I do that, I need to get my X value, okay? My X value is always going to be this, the solubility of a particular product. Okay, it's in grams per liter. I just quickly change the moles per liter, which I've done over here. I get my compound here. I break it up into its anions and cations, like I've done over here and like I've done in my little formula over here. So they gotta multiply with each other eventually. So this Ni, again, it needs to balance out. So then this has to become a 3, then this becomes a 2. Okay, so I do the same thing down here. I create my little ice table. This is what I get down here for my Ni and for my PO4. So it's important to note that the Ksp, like we said, it's this formula here, this product times this product, but it's important to note that the coefficients that we get in the ice table need to go on top as a power now, same as this one. This needs to go on top now as a power. So again, this, like I said, it was our X value, so I'm just going to be putting that X over here, and I get that X value and I put that in to our equation. So this is what I get near on the bottom. I multiply them, I get my Ksp value there. These are the 2 green questions of the day. Please try these on your own. I'll be giving you the answers shortly. This is the answer to the first question. This is the answer to the second question.